yes. Look, you have to go through your textbook. This diagram, can you see this diagram on this slide? This I copied and pasted from your textbook. Okay, so many things from the directly. If you read the textbook, it's so easy, and they underlined the main points also. They highlighted, not underlined, they highlighted the main points also. Do you go through your textbook or not?
I do.
Yeah, everyone has to go through a textbook. You get a lot of questions from there. In the lecture, we don't have time to do so many questions, no? And it's given so colorful diagram, so interesting. There are a lot of questions. Please solve the questions. If you solve all the questions, and there are small quizzes in the ebook, Smart Book. There is something called Smart Book, no? Maybe you have seen it. You gave too much money and you bought the book, so you need to make use of the book, my dear students. Don't just depend on the lecture, because we have limited time. So during lecture we do only a few questions. We cannot do more questions, so the extra questions you need to take from the textbook. It's very nicely arranged, so good, and so many questions are there. Please do it. Okay, so this diagram I took from the textbook. Look. So here, listen, can you see this as per, did you understand something from the diagram? We are going to do something called equilibrium. Equilibrium means some sort of balancing. It's kind of balance, okay? It goes in the forward direction, and see, look at the arrow. It goes forward, then it comes backward, okay? Now here, this vessel contains water. Can you see water? Water is there, H2O in liquid state, and it's kept in a closed container. See, can you see it's kept in a closed vessel? The vessel is closed, nothing can go out. Can you see the red colored things? These red colored things are the water vapor. Okay, this is water vapor. So liquid water goes to vapor state. Vapor means Bukhar state. So since it is in a closed vessel, the Bukhar cannot escape. So in this vessel, inside this vessel, it can have some amount of Bukhar. It cannot hold too much Bukhar. So what will it have? What will happen? The Bukhar will start condensing. You know the meaning of condensing? Vapor, Bukhar will become liquid. Did you get some point? Did you understand something what I'm telling?
Yes.
Yes,
Because
yes.
I don't know Arabic terms, so that's why. Okay, dears. So that means initially liquid water is going to the vapor state, Bukhar state. And then from Bukhar state, it will come back to the liquid state. Okay, understand the meaning? So after some time, so it's initially the rate of formation of Bukhar is more. And then after some time, the rate of condensation will occur, and then it will reach equilibrium. Equilibrium means it's balance. So that means speed of the forward reaction, that means speed of this will be equal to the speed of this reverse reaction. So at that time, the system will reach equilibrium. Did you understand the meaning of the term equilibrium?
Yes, doctor.
Yes.
Okay. So here the equilibrium is between liquid water and water vapor, liquid and gas. Okay, so you have an idea about equilibrium now. Look, now there are so many misconceptions related to equilibrium. Always people get confused with this one. See, can you see I did so many diagrams? Some diagram I did with pen because it's taking too much time to draw it otherwise. Okay. Look here. Here, what it's like so many information on this page. Look here, for a reaction, reactants is getting converted to products. You know the meaning of reactant and product, right?
Yes.
Yes.
Okay. Oh, sorry. Okay. Suppose you have a reactant. The reactant is getting converted to product. Okay, look here. Initially, at the beginning, the concentration, Turkish of the reactant, look, Turkish of the reactant is maximum, right? Correct?
Yes.
Correct. And what about the Turkish of the product?
It is minimum.
Yeah, it is 0. Turkish of the product is 0 because we didn't start a reaction. Now, there is a graph. Can you see here I wrote concentration Turkish. Instead of concentration for gases, concentration can be expressed in terms of partial pressure. Pressure means duct. Okay, partial means it's the pressure of each gas is called partial. Partial has no significance here. Okay, so you can express the concentration maybe in terms of molarity, or it can be in terms of partial pressure duct. Okay, is it clear for you? Understand? Now on the x-axis I wrote a reaction coordinate, or progress of the reaction, or with time. It's easy thing is it's time. Okay, understand what
Yeah.
I meant? Okay, so now here what happens is look, initially the concentration of the product is maximum. With time, initially concentration of the reactant is maximum. With time, concentration is keep on decreasing. Then when it comes to product, initially the concentration of the product is 0. With time, concentration of the product is increasing. Okay, you understand? After at this stage, can you see at this stage, Turkish of the reactants is equal to, okay, is constant. It's not changing. Turkish of the reactant is not changing. And Turkish of the product also is not changing. It is constant. Did you understand?
Yes, doctor.
Okay,
Yes.
so that means this is the first thing. At equilibrium, the reaction is not stopping. Okay, understand what I meant? Okay.
Doctor,
Now, yes, dear.
what about when the two lines cut each other?
Wait.
Not
Let me
so.
tell my dear. Let me complete all the things, and I will give you time to ask questions. Okay. Let me complete this full slide because this is confusing thing if you don't understand. Okay. Now, according to the first graph, here at equilibrium, concentration of the reactant is constant, concentration of the product is constant. It's not changing. Means speed of the forward reaction will be equal to the speed of the backward reaction or reverse reaction. See, if you go, okay, and then I'll come back to that. Now this is another one. Here again, Turkish of the reactant is, okay, look, it is decreasing, and Turkish of the product is increasing. At equilibrium, concentration of the reactants is equal to the concentration of the product. Okay, now look at this case. In this case, concentration of the product is, see, look here, it is constant. Concentration of the reactant also is constant, but they are not equal. Did you understand?
Yes.
Okay,
Yes.
so now
Yeah.
from all these things, which all points you can get? At equilibrium, reaction is not stopping. Speed of the forward reaction is equal to speed of the backward reaction. Concentration of the reactants and products remains constant. Understand? See, look, at equilibrium, concentration of the product is constant, concentration of the reactant is constant. Here also it is the same. Here also it is the same. Then third point, last point, concentration of the reactants can be equal to the concentration of the product. Look over here, my dear students. Don't mistake. I mean, take it like mistaken. See, look. In this case, concentration of the products constant, concentration of the reactant constant, but they are not the same. Are they same?
No.
No. Here are they same?
No.
Here are they same?
Yeah.
Yes.
Yes.
Yes. So that means concentration of the reactant can be equal to the concentration of the products, but not always. Is it clear for you?
Yes.
Okay. Now look at this graph. For all these things, the graph number 1, graph number 2, graph number 3, all these cases, this remains the same. Rate. Can you see this graph is related to rate and time? Rate of the forward reaction is equal to the rate of the backward reaction at equilibrium in all these cases. Is it clear now? Is it clear now?
Yes, doctor.
Yes.
Now look, another point. Suppose this is 0. This value is number 1. Okay. Suppose this value, this value is 1. Just imagine. This value is 1.5. Did you understand what I meant? Here, look. See, let the concentration of the reactant, let it be 1. Concentration of the product, let it be 1.5. Okay, so you can find equilibrium constant K. Can you see K? I will explain this K in detail later on. K means actually in this case, concentration of the products over concentration of the reactant, right? So here concentration of the product is 1.5. Sir?
Yes.
Yes.
What's the concentration of the reactant?
1.
1. So 1.5 over 1. That means equilibrium constant K is greater than 1. Did you understand?
Yes, doctor.
Okay, so now here look at this one. This value is 1.5. What is the Tarkis of the product? Tell me.
1.5.
1.5. What is the Tarkis of the reactant?
1.5.
Also
1.5. So equilibrium constant K is 1. So that means this is the one in this case. Is it okay?
Yes, doctor.
yes.
Okay. Now what about this one? Say this is a product. It is 1. Reactant 1.5. What's the answer? K is equal to 1 over 1.5. Equilibrium constant K is less than 1. So the meaning of this one is, look here, my dear. Here, K value is greater than 1 means you get more, come on, more
Products.
product. If
Product.
K is 1, product and reactant remains the same. It's not good method to make the product. In this case, you get less products. Why? The equilibrium constant K value is less than 1. If it is less than 1, you get less product. Understand the meaning? Is it
Yep.
okay? So that
Yes.
means reaction does not go more in the forward direction. It's more of reactant oriented than the product oriented. Okay, if you have any question, you can ask me. See question?
Doctor, in
Yes,
all these
doctor.
cases,
Yes, tell dear, tell.
in all these cases, the rate is always the same for the forward and
Yes.
reverse reaction, right?
Yeah, yes. At a particular temperature, all cases it's like that. Okay, if any question you can ask.
Doctor, what about the point when the two lines cut each other? It's not the same concentration?
Yeah, concentration same, no? You mean the middle graph? The one in the middle?
No,
The middle
no, the
graph?
first.
First graph? I didn't understand, my dear. First graph?
Yes.
I didn't get your question. First graph, tell.
When the two lines cut each other. The point when the two...
No, it's not reached equilibrium, my dear. Oh, okay, good, you asked me. See, okay, look, okay. See. This area, no, this, after, can you see the line here, line? After the line onwards, the concentration is same. So here it is reached equilibrium. Before this much area, not at equilibrium, not equilibrium. Got the point? Did you understand?
Yes.
Here also
Yes,
this much area not at equilibrium. Here also this much not at going to reach equilibrium. Okay, understood? Yeah, at equilibrium means concentration of the reactants should be constant. It should not change. See, it should be a straight line. Straight line, no? You know the meaning of term straight line, right?
Yes.
Okay, okay.
Thanks, Doctor.
Yes. Do you want me to ask to explain anything else? Did you understand this much? Did you understand?
Yes.
Yes, doctor.
Okay. So
Yes,
now,
sir.
my dear girls, what about others? Nobody else is there in the class? No.
I
Nobody else? Okay. Okay. Fine. I hope you understood everything. Now, see, one more point. For a reaction, this equilibrium, this K, I wrote K. Did you see? I will explain K in detail. Okay, my dears, don't worry. It's coming in detail later on. Okay. Equilibrium constant K for a reaction will be constant at a particular temperature. For one reaction, only one K value at a temperature. This K value is capital K, not rate constant. Rate constant in the previous lesson, it's small k. So for this particular reaction, always there is some value that will not change. Here also there is a value, it will not change. So equilibrium constant is a constant for it. This is the one given. The value of equilibrium constant for a reaction is a constant at a particular temperature. When you change the temperature, equilibrium constant value will change. Okay. Now, there are two types of equilibrium reactions. Can you read it please for me? What is written here?
homogeneous.
Homogeneous equilibrium. The other one is called heterogeneous equilibrium. The term itself is clear. Here all reactants and products are in the
Same phase.
same phase. Look here. Look, listen. This is gas, here gas, here gas. All reactants and products are in gaseous phase. Here all of them are in which physical state? Which physical state?
Aqueous.
Aqueous state. Aqueous means mahlul. All of them mahlul. Now, what is heterogeneous? You understood the meaning. Here, all reactants and products are not in the
Same phase.
same phase. Okay, see, look, why? This is solid, this is solid, this is gas. Understand? Okay, suppose if it is solid and liquid. Okay, so if they are in different phases, if they are not in the same phase, okay, it will be heterogeneous. And if they are in the same phase, it's called
Homogeneous.
homogeneous. Okay, you want okay, any question? Anybody has any doubts?
No, Doctor.
Okay, understood, right? So I'll move to the next topic. Okay. Now, how to write the equilibrium constant expression Kp and Kc? See, look here. I will write it and show you. Just imagine for a reaction, we have a reaction A giving B. This is gas, this is gas. Okay? Okay, at equilibrium. So a ratio of, or the Turkish of the product over Turkish of the reactant is called equilibrium constant. This concentration can be expressed in terms of molarity, or it can be expressed in terms of pressure. So look here, equilibrium constant K in terms of concentration, Kc is equal to concentration of B over concentration of A at equilibrium. Did you understand? Product by
Reactants.
react. Suppose if it is A plus B giving, sorry, I will write Kp also. Kp. What is Kp? It is the pressure of B over pressure of A at equilibrium. Did you understand?
Yes.
Okay,
Yeah.
so now A plus B giving C plus D. Suppose if this is the question, Kc will be equal to concentration of C times its multiplication, don't add. Concentration of D over concentration of A times concentration of B. Okay, did you understand? Or Kp will be equal to, tell me, pressure of C over pressure of D multiplied by pressure of D over pressure of A times pressure of B. Is it okay?
Yes.
Yes.
Okay, so then now, suppose if the question is 2A giving 2B. Can you tell me what is Kc expression?
We will multiply by 2.
I don't know. What do you think?
2 multiplied by the concentration of B over 2 multiplied by the concentration of A.
One more time.
Maybe will be power.
Oh, excellent. Look here, my dear. See, this is B to the power 2 over A to the power 2. You understand this one, or you want me to explain?
Yes,
Do you want me to explain?
No.
You don't understand?
Because C multiply with C.
Yes, yes. Good, good. Very good, my dear. What's your name, my dear?
Arrow.
Arva. Arva, how much you got in the exam? Full mark?
No.
Okay, it's okay.
Each chapter is from school already.
School you studied, okay. So it is, if you don't know, A plus A giving B plus B. Okay, so Kc will be equal to B times B over A times A. So that is B square over A square. Okay, so similarly you can have Kb also. Did you understand? Is it okay?
Yes.
Okay, so now similarly, or general equation I can write A, see, just all of them are gases, okay? Imagine all cases, all are gases. A plus BB, all just gases, giving CC plus DD. Okay, so how do you write Kc? Tell me Kc.
A to the capital to the power A small letter.
Yes. Concentration of C to the power C. Concentration of D to the power D over concentration of A to the power A and concentration of B to the power B. Okay, or in short, the coefficient will become the
power.
Okay, yes. Now the meaning of this one, do you know the meaning of this one? What's the meaning of the square bracket? The square bracket means concentration, molarity, mole per liter. Okay, so this is what. Now I will just write a few questions. Okay, suppose if it is question number 1, N2 plus 3H2 giving 2NH3. Here it is gas, here gas, here gas. Okay, yeah, okay. So what is Kc? Tell me.
NH3 to the power.
Yes. Concentration, you must tell concentration. Square bracket means concentration. Concentration of NH3 to the power 2 over concentration of
N2 concentration of H2 to power 3.
Power 3. So Kb
is the same, but the pressure.
Yeah. Pressure of NH3 to the power 2 over pressure of N2 times pressure of H2. H2 to the power 3. Is it okay? Yeah. So suppose you have. Yes. Come on.
Concentration of NO to the power 4.
Kc is equal to concentration of NO to the power 4. Yes.
Multiplied by concentration of without
Concentration of NH3
multiplied by concentration of O2 to the power 5.
Did I miss something?
The H2O is liquid, so we don't add it.
Yes, my dear, this is something very important. Turkeys of liquid is taken as 1. Turkeys of solid also is taken as 1. Liquid and solid taken as 1. Okay, aqueous we take, but solid and liquid, you take it as 1. So this is times 1 to the power 6. That means 1 to the power 6 means nothing but
1.
1. Is it okay? Understood?
Yes.
Okay, look. Okay. Yes, come on, my dear, tell me.
Concentration of O2.
Yes, dear.
Doctor, there is one error. We cannot
There is-
find Kc and Kp.
Where, my dear? Oh, I didn't write Kp. Okay, fine. What is Kp? Pressure of NO to the power 4 or pressure of NH3 to the power 4 times pressure of O2 to the power 5. Okay, my dear Arwa?
No, doctor, I mean the equation. If it has one error, not two errors, we cannot find Kc and Kp.
Errors in the sense, what do you mean by error? What did you mean? What?
She means that the reaction goes only in one side, not two sides.
Yeah, okay.
Because we have Kc and Kp for that reaction.
Oh, just one side reaction you are asking me. If instead of both sides. Not, my dear, this lesson is related to equilibrium reaction. So we go for equilibrium constant Kp and Kc for equilibrium reactions. But I will mention something else related to this. See, actually, for all reactions, there is some equilibrium. Okay, for all reactions. Now, I'll go back to the slide. See the first one. So can you see the first slide? We started with this. Okay, my dear Arwa. Okay.
Yes, doctor.
Some cases, no, at equilibrium, Turkeys of the product is very, very high when compared to the Turkeys of the reactant. Okay, just imagine in this case. Okay, suppose if K value is concentration of the product by concentration of reactant is 10 to the power say 100. Just imagine 10 to the power 100 or 10 to the power 25 or 25 power 30. Something like that. You understand what I meant? 10 to the power 100 or 10 to the power 25. Okay, so this K value is so high. What do you mean by K value very high? Turkeys of the product will be very, very, very high when compared to the Turkeys of the reactant. Understand?
Yes.
Okay, so in that case, so reactant is getting converted to product. So Turkeys of the product is too high means reaction, most of the reactants are getting converted to product. So the reaction is kind of leading to completion. You understand? The rate of the backward reaction is very less when compared to the rate of the, not rate of the rate will be at rate will be always, it's like a constant, but the amount of the product formed will be too high means it has less tendency to go in the backward direction or less tendency to get the reactants. In that case, we don't write R giving P. Instead, we write R giving P like this. It's clear or you got more confused?
Yes, doctor.
What confused? You understand?
No. Yes.
Okay, yes, that's it. So that means I'll give the summary. For every reaction, there is an equilibrium. But some cases, most of the cases, you get more products when compared to the reactants. So we neglect the backward direction now in that case. So we don't write reversible arrow. Instead, we write only single arrow. Okay? Understand?
Yes.
Okay. Yes. Okay. Now, we were on which slide? This one, right? Yes. Okay, my dear, look. Even for this reaction also kind of like that. CaCO3 solid giving CaO plus CO2. What's the equilibrium constant Kc? Tell me the value of Kc.
It's equal to the concentration of CO2.
Yes, it's equal to the concentration of CO2. What is Kp? Kp is equal to the concentration of, pressure of CO2 at equilibrium. My dear students, what is the meaning of this? Tell me.
That at the equilibrium, all the CaCO3 becomes CO2.
No, it's not like that, my dear. See, look at the diagram. That's why I did this diagram. See, this diagram also is from your textbook. I just copied and pasted. Okay. Look here. So in the first diagram, look, the amount of the thing. See, here it's written in the figure. Here the green one is, can you see green one is CaO? And the orange color or red one is CaCO3. Did you see the thing? CaCO3 here. This is CaCO3 and green is CaO. Okay, here it is switched. You understand what I meant? Okay, clear for you, or leave it. Okay, A and B equilibrium pressure of CO2 is the same at a particular temperature despite the presence of different amount of CaCO3 and CaO. You got the point or not? Did you understand? You want me to explain again?
Yes, doctor.
Yeah,
Dr. Amin,
Yes, I will explain. Okay, look over here. Where is it? Okay. Oh, yeah. Okay, let me remove it.
Dr. Amin, when we add more CaCO3 or CaO, it will be the same, Kc and K.
Yeah, that's it. That's the meaning. That's the meaning. Okay, look. In the first case, first diagram, here the amount of CaCO3 and some amount of CaCO3 is there, some amount of CaO is there. Now in this vessel, the amount of CaCO3 and CaO are different. So that means CaCO3 and CaO, the mass of CaCO3 here and mass of CaCO3 here are not the same. Similarly, the mass of CaO here and CaO here are not the same. But look at the amount of the CO2 present. 1, 2, 3, 4. How many are there? 2, 4, 6. Here also how much? 2, 4, 6. That means at equilibrium, the concentration or pressure of the CO2 remains same for this reaction, whatever be the amount of CaCO3 and CaO are taken. So equilibrium constant K or the amount of the CO2 does not depend on the amount of CaCO3 and CaO. Understand what I meant?
Yes, doctor.
Anyone has doubt? Anybody has question? Do you have any question?
Doctor,
Yes.
how it does not depend on the reactant? Then it depends on what?
No, dear. So you are taking CaCO3. You take some amount of CaCO3 at a particular temperature. It's very important. Okay. Suppose if it is at 50 degree, or take 100 at 100. It takes 100 grams of CaCO3. Heat it to 100 degrees Celsius. So it will produce some amount of CaO and CO2. So you understand? Understand?
Yes.
Okay. Now next time take suppose 300 gram of CaCO3 and heat it to 100 degrees Celsius. Same temperature, that's very important. So it will decompose and it will give CaO and CO2. You can see that amount of CO2 present in the second case also will be the same.
Okay, got it.
Now you understood?
Yes.
Understood? But if you want to change it, what you can do, if you want to get more products, what can you do? Instead of 100 degree, make it some other temperature. If you change the temperature, the CO2 value will change. But with it does not depend on the amount of CaO and CaCO3. Understood now?
Yes. So the balance goes to CaO, not to CO2, right?
Yeah, because the remaining things it goes forward and backward now, my dear. So that means CaCO3, if you are we have only, just imagine we have initially only CaCO3. A part of CaCO3 will be converted to CaO and CO2. Understood?
Yes, doctor.
Okay. Now, next one. This we did already. This also we did already. Now, what is the relationship between Kp and Kc? Okay, see, what is it? What is written there? What is written here? Come on, tell me.
Delta N.
Kp is equal to, Kp means equilibrium constant in terms of pressure. Kp is equal to Kc RT to the power delta N. Here delta N, what is delta N given? Come on, what is written there?
Moles of gaseous products.
Yes. Number of moles of gaseous products minus number of moles of gaseous reactant is, there is actually derivation in the, there is a derivation for this equation, this formula in the textbook. If you want, you can refer. Okay, because we don't need the derivation, that's why I didn't do. In the textbook it's written Kp is equal to Kc RT to the power delta N, where Kp, you know what Kp is, you know Kc is. R here the value is 0.0821, not 8.314. This is another important thing. Okay. Then temperature value, always we use common temperature. Here it is Kelvin. Okay. Delta N is the number of moles of gaseous products minus number of moles of gaseous reactants. And now that's the question. When is Kp? When does Kp equal to Kc? Okay, Kp can be equal to Kc when delta N is
0.
delta 0. So something to the power 0 is equal to
1.
1. So Kp is equal to Kc. Okay. Okay.
Okay, doctor.
Now, yes, you help me to do this one. For a reaction N2 gas plus 3H2 to this one, Kp so and so find Kc. Yes. Tell me please.
Kp is equal to Kc multiplied by RT to the power delta.
Delta N. First of all, we will find delta N. So what is delta N?
Number of product
Number of moles of
gases.
gas product minus number of moles of gaseous reactants. Yes, tell me products, how many are there, dears?
2
Two.
moles.
Reactants, how many are there? Here it's 1.
4.
1 plus 3. So 2 minus 4 is equal to
Minus 2.
minus 2. Now, Kp is equal to Kc RT to the power delta N. So, Kp value is 1.5 10 to the power minus 2 is equal to Kc. R is 0.0821. T is, come on,
500.
600 plus 273.15.
273.15. Okay, raised to delta N minus 2. So that means this goes down, right? Minus, you know how to do the calculation, right?
Yes, doctor.
Okay, so that is 1.5 10 to the power minus 2. Okay, times 0.0821 times 500 plus 273.15 the whole raised to 2 is equal to Kc, correct?
Yes, doctor.
Okay, now tell me the answer, because I want to do it in scientific notation, because scientific notation always you make mistake. Next imtihan, we will not recorrect the paper, okay? So be careful, it's your responsibility, okay?
It's 60.437.
60.437, okay, correct, right? So how do you write in scientific notation? How do you write? 6.04, okay, 10 to the power
1.
10 to the power 1, okay? Always there should be only one digit here. Okay, so that is scientific notation. Okay, now Kc is given, find Kp. Yes, come on. Tell me.
We will use the same formula and find delta n first.
Yes, delta n here, delta n, what's the value of delta n? Number of moles of gaseous products minus number of moles of gaseous reactants, that's equal to
4 minus 5 plus 4.
4 minus, don't take this because it's liquid.
4 minus
4
9.
minus 5 plus 4, correct? Correct?
Yes,
Okay, is equal to minus 5, right?
right.
Yeah. So Kp is equal to Kc RT to the power delta n. So it is Kc is, what is Kc? 4 10 to the power 5 times R is 0.0821. T is 400 plus 273 is 673.15 to the power minus 5. Correct? Yeah?
Yes.
Tell me the answer, please. Yes.
It is 7.75.
How much?
7.75
7.75?
multiply to 10 to the power minus 4.
10 to the power minus 4. Okay? I hope everyone understood. Next topic I will teach next class, because anyway we have only how many minutes? 3 minutes. Okay? So you have 1 week ahead, right? 1 week for what? 1 week, what will you do? You have holiday, no?
Yes,
Yes.
it's the midterm break.
So what are you going to do? Yeah, during break, what are you going to do?
Prepare for
Prepare for
the next half of the semester.
very good. Okay, so you enjoy maybe 1 day or 2 maximum. Okay, after that you start studying, so that because Ramadan is coming, so you will be so tired and then you can't study properly because of it's not easy for you to study. So it's better you study everything properly. Okay, and the next quizzes, I don't know when the next quizzes, I forgot the date, so that will be most probably from the previous lesson. Try to score full mark from that, and okay, enjoy also, little bit you enjoy and then study. Okay, labs, most of the labs are over, right? Lab reports, now you have 1 or 2, only 1 lab report left, rest all you finished, right?
We finished
Yes.
it.
Yeah, so it's okay. Yeah. Okay, so now, so see you after a week. Yeah.
Okay.
Okay, my dears. Okay, bye bye.